Okay, we left off with problem number 9. We're on number 10. So this is where you're going to have to think a little bit more abstractly. You might want to use all students take calculus because that's about the easiest way to figure this out. So they're asking you what quadrant you're in. So A for all, this would be students. We're going to go by the first letter, take calculus. Remember, this first letter of each word tells us what is positive. So here it is, the sign is positive as well as its reciprocal cousin. Everything else is negative. Here, that's self-explanatory. All trig functions are positive. Here it would be tan is positive and its reciprocal cousin. And then everything else of the 6 trig functions is negative. Here it would be cosine is positive and its reciprocal cousin. And we're going to use that knowledge to help us answer this. Go to where sine is negative. Nothing's negative there. Sine is positive here. So this condition that you're looking for, I don't care what condition they throw at you, that specific condition is always going to be true in 2 and only 2 quadrants. So if you already know that sine was positive here and here, that means sine has to be negative here and here. Okay, so for any condition they give you, it will be true in exactly 2 quadrants. Tan is negative. Well, nothing's negative here. Tan is negative. Well, these are the only 2 that are positive here, so therefore tan has to be negative here. And then let's keep going. Tan is not negative here, but it is negative here. In the end, there were 2 conditions that you were looking for, where sine is negative as well as tan being negative. Notice of these 4 quadrants that the only quadrant that satisfied both of these conditions was right here in quadrant 4. So you are in quadrant 4. Okay, moving on to number 11. Let's see if we can do that one as well. Okay, same kind of philosophy in numbers 11 and 12. Okay, this is students. So in other words, sine and cosecant are the positive ones. Take, all students take. This will be tan is positive and cotan. And calculus, all students take calculus. So this will be cosine and its reciprocal cousin as the positive ones in each quadrant. So we're looking for where cosine is negative. Okay, so everything's positive here, so it can't be there. Cosine, let's see, the only 2 that are positive is this and this over here, so therefore cosine is negative there. Then let's see, we know that this has to be true, this condition, in exactly 2 places. So let's see, what is positive here? Tan and cotan, therefore cosine has to be negative. The only 2 that are positive are the ones that are mentioned, and everything else is negative. And of course it says flat out right here, cosine's positive. So okay, we satisfied that. Now let's go look for where this condition is satisfied, cotangent being positive. That would be here, where all trig functions are positive. And then let's see, by the time you get over here, let's see, where else is cotan positive? It's here and also here. Okay, so now looking at this, the only quadrant that satisfies both cosine being negative and cotan being positive is in quadrant 3. Same question for number 12. I don't know, once you mess up that graph, I don't know if you want to reuse it, it'll just be confusing. These are a little bit confusing, these problems anyway, so you might want to start with a clean slate that doesn't have any marks on it, or keep reusing the same one if you think you can. Okay, so cosine is positive. That would be here where everything is positive. And then where else does it say cosine is positive? Right here. Okay, so we did this one. It always, the condition always occurs in exactly 2 quadrants, so don't bother questioning yourself or wondering whether it's true anywhere else. Cotangent being negative. Now let's look for that condition. Okay, everything's positive here, so that can't be true. Sine and cosecant are the only positive ones here. Therefore, everything else, including cotangent, would have to be negative there. Okay, now so far I've only found one spot where cotangent is negative. Let's continue. Cotangent is positive here, so therefore it has to be here where it's negative. Okay, only place that satisfies both conditions is in quadrant number 4. Okay, moving on. Let's see what else is on the theorem page. I believe we could have done 7 through 12. We'll see if we could have done anything further. The rest of this is just a review of what I taught you in section 6.1 and 6.2. Here's all the formulas all over again for sine, cosine, secant, cosecant, tangent, and cotangent. I just figured I would repeat them here for you because they get used again and will be used throughout the remainder of the course. Very heavy in formulas. Notice that is one thing that is different than MAC1105. There weren't anywhere near this many formulas. So put just as much work into memorizing these formulas as you are into being able to actually calculate answers and draw graphs. For reference angles, this again, repeat of what we really hit in section 6.2. What happens with the legs when you're constructing a triangle inside a unit circle? That's why the hypotenuse is 1. Both legs are square root of 2 over 2. Here the long leg is square root of 3 over 2. And remember, that long leg is always opposite to the 60-degree angle, whereas the short leg is always opposite, in other words, across from the 30-degree angle inside your triangle. Don't forget that. Okay, now we can do numbers 13. Use the given sides and to draw triangles. 18, 19. Let's just get into the problems and go as far as we can. So here's number 13. You're doing the sine of 405 degrees. So let's just draw that. Okay, so if you're going 405 degrees, obviously you're going to go past 360 and you're going to go an additional amount. That additional amount is going to give you a special right triangle so that you will be using the formulas that we just reviewed on the theorem page. So you're going to go 360. And if you don't know that you need an additional 45 degrees to get from 360 to 405, then you should just put it in your calculator. Just go, okay, I want to get to 405, but I've already traveled 360, so take that out. There's your additional 45 degrees. So you're going full revolution and then an extra 45 degrees. Okay, if that's 45 at the center, in other words, the central angle, then so's this. For those from your memorized formulas, because you don't want to have to take out the formulas each time. You need to memorize that both legs are square root of 2 over 2 when you're in a unit circle. You can wrap the unit circle around there if you want to, but not really necessary. And then answer what the sine is. The sine is y over r. That's the definition for sine. So that's the y value. Remember, the leg that goes up and down is the y value. The leg that goes horizontally is the x value. Okay, so it's just square root of 2 over 2 over 1. Okay, and using number 14, we're going to do cosecant. You're wrapping all the way to 750. So if you were going to go to 750, you'd have to wrap around once. That's 360. Wrap around again. 360 and 360 is 720. And if you want to get to 750, you have to go an additional 30. So you're going to go like this. There's your additional 30. Remember, this is the rotating arm right here, the hypotenuse. It has wrapped around once, twice, and then gone beyond the 720 mark, an additional 30 up in the air, landing right here in quadrant 1. If this is 30 degrees at the center, then this would be 60 degrees up here, making this the short leg and therefore being 1/2, while this is the long leg across from the 60, therefore being square root of 3 over 2. And of course, you're in a unit circle, so the hypotenuse is 1. So what is the cosecant? Remember, cosecant is related to sine. Sine is y over r, so this is r over y as your definition. So 1 over, when the r is on the bottom, r is always 1 in the unit circle. You don't have to write it, but you're going to need it right now so you realize that you're in a reciprocal situation. And then the y value is 1/2. If you're going to simplify a fraction like this, a fraction within a fraction, just take the denominator, float it to the top, and multiply by the reciprocal. In other words, flip it over. So float and flip. Cross this out so you don't think that you need to deal with it anymore, and give the answer. 1 times 2, 2. That's your final answer. This was the final answer here. Moving to 15. Use the fact that the trig functions are periodic, find the exact value. Okay, that's what we've been doing. That we know that as we spin past 360, certain value, the trig values are going to repeat. Okay, so this time, now it's up to you if you want to leave it like this. You can leave it like this if you're okay counting in thirds. If you're happier doing it in degrees, you could also do that. So let's see, if we did do it in degrees, it would be 13 times 180 divided by 3. Let me put that in there in case somebody goes and looks at this later and doesn't know how they got that. 13 times 180 divided by 3. If you want to do it in degrees, I don't know what you're going to be more comfortable in. 780. So you're doing the sine of 780 because that's the same thing as 13 pi divided by 3. Let me make sure 13 times pi divided, yeah. Okay, so that means, just as it has meant in the number 13 and 14, to rotate to this location and draw your triangle. Okay, so if you're going to go to 780, you definitely got to rotate twice, 360, 720, and then ask yourself, if I'm at 720, how much more do I have to get to here? An additional 60 degrees. So this rotating arm rotated once, twice, and then an additional 60 up in the air. That makes this the long leg, or in other words, square root of 3 over 2, always across from the 60. That would make this the 30, because we already know that's the right angle. Therefore, this would be the short leg, being 1/2, and of course the hypotenuse is 1. So when you're asked, what is the sine for a picture that was drawn by rotating to 13 pi over 3, or in other words, 780, what is the sine? Well, every trig function has a definition. Sine is defined as y over r, so it is square root of 3 over 2 over 1. Now, since it's just over 1, I'm not going to write that, so that's your final answer. Okay, moving to number 16. Number 16, you will not be able to draw the triangle because you're at a quadrantal position, a quadrantal angle, as it's called. That means that when you rotate, you land smack dab on one of the axes, which is going to be the case here. So just think about it. Where you're really at is 0 when you rotate to 24 pi, because this is 2 pi, 4 pi, 6 pi. Notice that these are even, all even multiples of the pi puts you right back at 0. So you're going to land right here when you rotate around 24 times. 24 pi, not 24 times. Okay, so you'd be rotating around there 12 times. Each of those 12 times gives you 2 pi. You're at 24 pi. So you're right here. So think about, you're in this unit circle, and you could wrap unit circles around these things too. This would just be the radius of the circle. It's just kind of hard when you're trying to wrap it around a triangle, so I don't bother. But here, if you're in a unit circle and this is 1, that means that this is 1, 0. Your radius is 1. You're looking for the sine, which is y, over r.